And that brings me already to our first speaker. For today, we would like to begin with David Gradl, and I'd like to briefly introduce you before handing over to you, David. You are the CTO and co-founder of mycolutions, a deep tech startup developing mycelium-based materials for construction and acoustics. And as an environmental engineer from Hamburg, you focus on bio-based materials and have been advancing also the industrialization of mycelium composites since 2021. And mycolution uses mycelium as a renewable carbon binding resource to produce modular climate positive insulation and acoustic panels that replace conventional materials and support a circular economy. Your work also centers on scaling these solutions to deliver both ecological and economic benefits, helping to turn mycelium from a niche product into an emerging industry standard. So we are very interested and excited. And with that, I hand over to you, David.
Thank you so much. Thank you for having me. Can everyone see my screen?
Yes.
Perfect. Yeah. Thanks again for having me. I'm David from mycolutions, and we develop circular and healthy materials with the help of mycelium. My two co-founders, Thies and Helge, we both three of us, we are environmental engineers, and since our studies, we were focusing and always looking for like solutions which already exist in nature to help us in our living environment to make our living better. And as all three of us also playing in a band together, there was this moment where we looked in the rehearsal room on the styrofoam, which is like placed everywhere in these rooms, and we thought, okay, what's this? What is this material, and are there better solutions? And we got a deep dive into that, and we saw, yeah, the acoustic industry and the construction industry in general, they face like pretty big problems. On the one hand, there is this pull factor that a lot of architects around there, especially in Europe, see sustainable materials as a key, and they as a key selection in their criteria to use the materials. On the other hand, we also have these push factors with the building directive, which is coming soon to us in Germany as well, where we have binding mandatory CO2 limits for buildings. And when we look on the market, we don't see real sustainable alternatives. Most of the acoustic materials, for example, are fossil-based or mineral wool. And on the other hand, these materials can also make us sick, and they emit microplastic and VOCs during their lifetime. So Helge once came up with the idea, hey, what about mycelium? Can we use this? And what is mycelium? It is actually the root structure of the fungi. And when this fungi is growing in the forest and looking for nutrients, the small root structure is going everywhere and trying to digest the nutrients. And we adapt this ability to a technology and give this mushroom agricultural residues like straw and the right conditions, and it will grow through the straw and make it bind it together to a stable composite material. At the end of this process, we kill the fungi by a drying process, and this is what we get. We have like a technology to build like porous bio-based composite materials. And this material is just perfect for markets like acoustics, thermal insulation, or even furniture. And when we look at the advantages of this material, of this technology, we see in comparison to synthetic forms, we have direct lower CO2 footprint. We designed this material to be compostable 100%. This is like a key and very important factor for us. It includes no toxins. There is no synthetic binder included, no fire retardant. Then a very important factor nowadays is also the substrate we use, like straw. This is a fast-growing raw material which is very abundant here in Europe. And on the one hand, we have like short supply chains and get value to these materials, but on the other hand, we also get the sovereignty about our materials again. So to produce these materials, we can source directly here in Europe, and even this time, this is going more and more important. And when we do it right, we can have a cost-efficient production of this material. And what did we do? So we saw, okay, we can start with a product in the acoustic market. So we developed an acoustic absorber. This is a product you can use in, yeah, for example, in retrofitting or existing buildings when you have this problem of noise. So people are talking, you have a long reverberation time, the people talk louder and louder to understand each other, and the problem just goes up. And with these kind of absorbers, you can dampen the sound and make the place more cozy again. And here you can see some applications of our absorbers we have on the market. And the key points of this product is on the one hand, this material is really new. The people never touched it before. It has a real pleasant, natural aesthetic and feeling. And there's a real fascination for this material. It's coming with really good acoustic conditions. It's, as I said, it supports a healthy indoor climate. It sequesters biogenic CO2 within the product, and we can produce it locally here in Germany. Um, these absorbers come, we sell them for 30 euros a piece, and roughly 10 pieces are 1 square meter. So the square meter price of this for this product is 300 square meters. This is the one side of our business model. On the other hand, we also work with acoustic manufacturers who want to work with this material. So when you see more and more like bigger companies who introduce mycelium products, um, it's very yeah, it could be that we are like the producers in the back end from them. So this is also like a good case for us. What we did, yeah, on the one hand, on the biotechnology side, we standardized the process. On the other hand, we yeah, verified the acoustic efficiency. So we have like a sound absorption class B for this absorber. In the mid spectrum, frequency spectrum, we have a very good absorption. So for the human voice, it's very effective. On the other hand, we built like around the product a mounting system, which is modular and is easy to install on any kind of walls. So we can just include this product. And this is the one thing. So the acoustic market, it was a first go-to-market strategy for us. On the other hand, we see like the insulation market, which is very important to change the materials we use there. It's a very difficult market because the volumes are very high, the margins are very low, and the regulation is also very high. So this is the next step we want to do, but still we are not that far like in the acoustic market. And but we are working on that. And one important thing, of course, is the fire retardancy. Untreated mycelium has more or less classification, Euro classification of E. We see that it's important to go to B, so we work on that, and are in the process of patenting fire-safe mycelium technology, which is of course by design circular and non-toxic. And yeah, that's the vision for the future. And when you're interested in the acoustic materials we have on the market so far, please reach out, and thank you very much.
Thank you, David, for this very interesting insight. Um, I would straight away move to our next speaker, and for that, share my screen again and save the questions for. And with that, we are
Oh, sorry.
with our next speaker, Stefan Friebel from Fraunhofer WKI. And also, I would like to introduce you with some words. You earned your PhD in polymer chemistry from Durham University in the UK in 1995 and the Fraunhofer Gesellschaft, where you are now a senior project manager at the Binders and Coatings Department at the Fraunhofer Institute for Wood Research, the WKI. And your work focuses on synthesis and characterization of novel bio-based functional resins for coatings. And you place particular emphasis on using naturally derived raw materials such as vegetables, oils, sugars, lignin from pulp and paper production, and byproducts from emerging biorefineries. And in your current project, you are developing a biosourced polyurethane lignin foam. And in your presentation, you will explore this topic in more depth and highlight the potential of lignin foams also for construction applications. Yeah, and so the stage is yours, Stefan Friebel.
Yes, thank you for the nice words of introduction. Yeah, as already mentioned, I will tell you something about our biosourced lignin foams, which we have developed. These are not real products, as my former speaker told you, explained to you, but we are on a good way, actually. So if we're talking about lignin, for those who are maybe not...
Sorry, you haven't shared your screen yet.
Oh.
Yes.
Now.
Perfect.
Okay,
now.
Sorry.
No problem. Thank you.
So for those of you who are not familiar with lignin, lignin is a part of the wood, and usually it's produced as a byproduct actually from the pulp and paper production. And you see some figures actually, and you see that the lignins which are on the market, which are available, are not all the same. So you have somehow to decide which type of lignin you will be starting with you, if you make a development. So you see the lignin sulfonate, the craft lignin or the soda lignin, and of minor interest is also the organosolv lignin, and they are soluble in water or in bases, organic solvents, and so on. And they differ maybe from the molecular mass. You see this molecule here, so the size of the molecule are different. Maybe for the lignin sulfonate is very big, and the craft and soda lignin are much smaller. Also, the availability is very important. And you do see that the craft process dominates everything. It's 85% of the total fraction of the pulp and paper production. And here we have 42.5 million tons every year available in the market. But most of the lignin is burned to run the process, and they're sending it as an energy source. And the material valorization is only 0.25 for the craft lignin, which is mostly available, and 33% of the lignin sulfonate, which is mainly used as, for instance, surfactants and so on. So pulp and paper is declining market. So paper is declining worldwide because we are in an electronic age now. Then the question arises, does lignin availability also declines? And I can give you the answer is, of course, no. Actually, it's increasing. This is because of the increasing number of biorefineries we've got, the lignocellulose biorefineries. So we have now about 100 million tons lignin available in total, both from the pulp and paper and the biorefinery. We actually use lignin from the biorefinery because it's sulfur-free and odorless, which was important for us, especially if we go into interior application. So if we look at foams, we have in general 3 different type of foams. One which is make physical, so the gas, the bubbles you have in the foam, they're introduced in the polymer melt, which are pressed under high pressure, and then when the pressure drops abruptly, the gas expands, and then you form the cellular structures. You know this as maybe the polystyrol. This is an example for it. You can also do a mechanical forming process. Then the air is mechanically incorporated into this polymer resin or paste. And then the mass will be somehow with a cross-linking agent will be then put into a solid state, so you will fix then the foam structure. An example is a mattress, for instance, with latex. And finally, the chemical foam, you have also resins or polymer melts, and you mix them with blowing agents, and then by heating or chemical reactions, these blowing agents decompose, release the gas, and finally you have the foam. So this example I will telling you today here is from the final one is the chemical source of foam. So look at the lignin. You here see the molecule. It's a highly functional macromolecule, heterogeneous, not soluble in common process solvents, I must say, which you use in the chemistry. So really saying it's a horror molecule for all chemists, because as a polymer chemist, you want to have a two functional molecule. Here we have, you see, maybe 25 or more functions in there. So we have somehow tam this molecule by a chemical trick. And this is what we are working on, and we manage it. So we have a polyurethane foam from lignin polyols, which we made. The lignin content is nearly 15%. This is only an example, so it's plus minus. The bio content for the moment is around 50%, but we are working now to go up to 85%. This is possible because we're using now a biosourced isocyanate as a second component. Density in this example is 42 kilogram per cubic meter, so it's very light foam, but we can go down to 30. And we can, by modifying the chemistry, we can make very soft foams, actually, which are very, very soft, but also extremely hard. That is maybe important for a different kind of application, and we can really control this. Now, I give you two examples actually, which we have done here in our lab. So we produced a foam and measured the thermal conductivity. So this is for insulation materials, and you see the thermal conductivity here in this example was 0.033 watt per meter per Kelvin. The density in this case was 31 kilogram per cubic meter. So that is quite good for a polyurethane foam. So we can compare this with conventional petro-based foam. So they're in a very similar range, actually. And second example, what we have done here is we make a lignin source sandwich composite. So we prepared these by direct forming the lignin foam onto a face sheet. And these face sheets, they consist of 100% biosourced lignin biopolymer plastic, which can be prepared by extruding process. And the interesting fact here is actually that we really can form it on these sheets. So this doesn't require any separate adhesive, so it will directly adhere to this material. So that is actually very comfortable. Possible application, I just want to draw your attention on, this could be also what I already mentioned, acoustic sandwich panels, for instance, can be used because we have an open cell foam which absorbs the noise very good. You can use this as maybe as a construction foam, but you can also use it as a partition sandwich panel, and you can maybe combine the properties. You can make this also with an acoustic sandwich panel, but also insulation board, so you can separate walls with this. For the very flexible forms, we can maybe make some 3D shapes, structural elements, also combining this with acoustic damping properties and also insulation, for instance. And another idea was to make these compression seal tapes, which are used if you build new houses, or also not redecorating, renewing old houses. Kilometers of these materials are used in these buildings, and you have then maybe a biosource alternative. Yeah, I think I'm finished. I hope I was in time. So if you have questions, requests, suggestions, please contact us. Thank you.
Perfect. Thank you very much for this insight into the chemical world, but also really showing possible applications for construction. Very interesting. Yes. And because of the time, I would directly go to our next speaker and our last speaker, who is Stefan Watzke from Parastruct. I will share my screen again. Yes, because I will also introduce you, Stefan, with a few words before we begin. You have a background in industrial engineering, interdisciplinary environmental and resource management, and marketing for sustainable development and circular economy. And you are here today for Parastruct. Parastruct, yes, at Parastruct, you are responsible for the market research, for the brand development, customer conversations, and strategic partnerships in the business development. And Parastruct enables affordable housing and economically viable buildings with added value through technology and building materials for closed material cycles. And today you will present us BioScreed, an alternative screed that acts as a carbon sink in buildings. And yeah, we will learn more about this, what it is exactly. And yeah, we are very looking forward to the presentation. I hand over to you.
Okay, hello. Happy to share some news from Parastruct. So our technology enables us to transform all kinds of mineral residues and biogenic byproducts into circular building materials. This is more needed than ever before, as living spaces are scarce and prices are overshooting, whilst we simply waste huge potentials. I mean, we are all aware about the challenges we face with fossil industries, but for most, it makes and will not make any sense anymore, even economic-wise, to go on like we did. It makes a big difference in addressing this massive CO2 footprint, and we start with subflooring. This highly important building structure causes about 5% of a building's overall emissions, and cement-bound screed dominates still the market, A, because they are affordable, and B, because they have optimized application processes. Whereas they demand long waiting times and most often additives for curing. Ecological alternatives are typically rare and cost-intensive, and therefore mostly applied in tiny niches in eco-construction. BioScreed changes this equation and brings together the advantages of both. It is ready for all variants and construction types as floating, bonded, or heated screed. This demonstrator shows the breadth and diversity of Parastruct solutions, from optional pipe equalizers to paving, all made from secondary resources and being circular. And it fits all project cases, whether in new buildings, extensions, or renovations. Dismantleable segment flooring will be realized in future, but now we are in the market entry phase and we focus and offer casted screeds. Key benefits include enhanced living comfort and saving a huge amount of CO2, as bioscreed is made largely from timber and sawmill residues. It can be produced and distributed quite regionally, therefore, opening up win-win business models for local businesses, whilst furthering an affordable, future-proof building sector. Particularly effective for low and medium temperature heating systems like they are used in timber constructions, bioscreed is warm underfoot and stores the heat exactly where one needs it, therefore reducing necessary heating energy. We at Parastruct believe convincing established businesses and craftsmen is key to realize the full potential of circular construction. Therefore, we offer a ready-to-use dry mix with common machinery and usual methods, enabling and boosting a fast adoption across industry. We achieve price parity with cement screed today due to a high yield. Our material is lighter and fills up more area at the same volume, and with rising CO2 prices will have a clear cost advantage, making circular materials also the economic choice. Bioscreed convinces with strong characteristics and performs near cement screed's standard impact sound level. And the low building moisture makes bioscreed rapidly applicable and walkable after just 24 hours, even at 6 centimeter thickness. Its low weight and high elasticity and fracture resistance makes it optimal for renovations, old buildings, retrofittings, timber constructions, but also for all other kinds of structures. Bioscreed corresponds to the key norms in the area. We've been conducting our life cycle assessment under supervision to date, but will be achieving the EPD as soon as possible. Bioscreed is directly reusable in powder form in same to higher trophic product levels, and we are intensively working on a reprocessing method for industrial scale recycling application for our binder. We are right now entering the DACH market with strong Austrian and European government support and focused impact-driven shareholders. And our growing pipeline with paying customers enables us yet 4 pilot projects over the span of the next 1.5 years, demonstrating bioscreed's viability to those who build. Project developers, planners, and builders benefit as being responsible today saves costs tomorrow for sure. Enhanced ESG ratings mean lower risk and better financing and funding options. For every product cycle, CO2 emissions are reduced even further and cutting the demand for raw materials significantly today, but foremost tomorrow. Right now, we are focused on bringing it to the market in pilot projects to establish a circular practice. Because together we can prove the viability of combining responsible and more affordable construction in a shared effort, we are sure. Future-oriented value creation can benefit everyone in the supply chain, plus those who use and live in our buildings. So saving resources, keeping them in loop, and offering win-win opportunities is crucial for businesses, for people everywhere, and the planet itself. This is how we see that Europe creates real sustainable competitive advantages and offers affordable living comfort. So please reach out to us to talk about opportunities for your specific projects. And yeah, also happy to answer any of your questions.